Okay, so we got another what is the minimum speed problem or maximum speed or yeah, minimum speed problem. So, you're swinging a bucket of water around in a circle. What is the slowest you need to go? So, at the very top of the circle, you got your bucket there and you got your water, and the slowest you can go would be the normal force would be 0, which means the only thing acting on it is going to be weight. So that means that mass times g is equal to mass times our radial acceleration. Mass is going to cancel again, so g is just going to equal our radial acceleration. And our radial acceleration, in order to find revolutions, we're going to need to use angular velocity. So angular velocity squared times r. Oh, and the reason we're using angular velocity is because 2 pi divided by angular velocity. Wait, no, that's completely wrong. Ignore that. The reason we are using angular velocity is because angular velocity is in radians per second. And if we multiply this by 60 seconds to the minute and 2 pi radians for every 1 revolution, then we're going to get RPMs, which is what it wants. So the square root of g divided by the radius is equal to our angular velocity. (9.8) divided by our radius. And we're going to start, if we draw a free body diagram here, this is going to be your shoulder here. So it's the length of your arm plus the length of the bottom of the bucket. So like your arm goes up to here. This is an arm. This is a really bad arm. And then you also got the bucket that keeps going. And so we need this point right down there. So your radius is going to be your 64 centimeter long arms and your 35 centimeter long bucket added together, which would give us 99 centimeters or 0.99 meters. So our angular velocity in radians per second is 3.14, basically pi. And so now we need to do this conversion up here. We're going to multiply it by 60, divide it by 2 pi, and we're going to get about 30 RPMs.